Okay, hello survivors. Let's see who's on. We've got one person already. Bloody hell, we're quick off the mark. Pop again, as always, pop your name in the chat box. Let's see who's about and who's not. I'm going to look at statistics paper today, I think. I reckon mechanics won't get done until after Easter. I mean, it'll be marked before Easter. Well, you know what I mean. Pop your name in the chat box for me. So got Alvin, brilliant. Katerina, just open my eyes. I mean, you're not much ahead of me. I mean, I woke up about 8:30 when I then sent you that message pretty much straight up. Austin, good. Sally, yes. Excellent, excellent, excellent. It's good to see all of you here. If you check your emails now, you will find that the mark scheme for the stats paper has been emailed to you. Hey, good to see both of you, Oliver and Eve. So that's what I want you to open up if you can. And we're going to talk through stats only, I think. 8:59, that's not bad. The thing is, I wish I could do something like, what the hell is that? But that's just not a thing. Steph, I have emailed the college to answer your message. If they haven't emailed back, someone sent me a message too. Okay. And they've now just emailed me back too. Okay, fine. I can see what I can do about that. I'm working on it, put it that way. No worries. I need to send them some more information, apparently. For some reason, they want me to send you. They want me to send you. It's not you. Send them your date of birth and your postcode. I'll forward the email so you can see this. This is weird. I'll look that up. Don't worry. Right. So we're up to about 5 people. That's a bit worrying. There were more people than that a minute ago. I will start in about 2 to 3 minutes. Get everyone a chance to catch up. While you're waiting, open up that email that I've just sent you. Hopefully you've got it. And have the mark scheme ready and your stats paper ready while we're waiting for everyone else to show up. We're up to about 6 people, which is a bit lower than normal. I guess it is 9 o'clock though, isn't it? So we'll just hold fire just for a couple of minutes. So what you're doing, you're getting your mark scheme open, you're getting your stats paper open. And in fact, I'm going to follow my own advice and do exactly just that. Get my papers open. Where are we? Year 13. So it's 31. Mark scheme there. And it was statistics, I think. There we go. We've got another person. Don't know who they are. Maybe we'll find out in just a moment. Okay. We'll start in about a minute. Is it going to be an hour and a half? No. No. We're only going to do half a paper each time. I got the idea from Monday that going that long is hard on people. It's hard on me too. So what I'll do, we'll do short bursts shorter bursts. No, it's not completely short. We're 45 minutes. Also, you don't have the mark scheme. We checked your email in the last 5 minutes. Because it literally was sent in the last 5 minutes. If you haven't, I'll send it again. Can we all check that? Pop that in the live chat. You haven't got the mark scheme. There's no reason why you shouldn't. We're down a few today. So again, pop your name in the chat box if you haven't already. Yeah, I get you. I agree. That's why we're shortening them. I'm with you all the way on that one. Katrina, you got yours. Brilliant. Up to 9th person. I say you can't find it. Literally check your junk thingy because you've got a problem with my emails in the past, haven't you? Or check in other. If not, can someone just email it to her? Hey, Alex, good to see you. So as it stands, I've got Alex, Katerina, Evie, Alvin, Steph, Eve, Oliver, Sally, Austin, and that's it. So if I haven't said your name, can you pop your name in the chat box? Because at the moment you're not getting registered. It's playing up. Okay, fair shout. That seems reasonable. I have no clue who. Oh, thanks. Yeah, that actually does make sense. Ilya, yeah, Ilya announcing he's Ilya is. I mean, that's a fair shout. Okay, cool. I'm gonna start in about 30 seconds then. If you still can't find it, can someone else just email it to her? Because it's not obviously not gone sent through me. I don't know why that is. Brilliant, thank you, Katerina. Much appreciated. We're gonna start in about 15 seconds. Oh, brilliant. Yeah, I mean, it's better having it on your laptop anyways, though, I guess. Right, okay, we're going to start. If anyone else pops up in the chat, just ask them to, to pop their name up. Right, let's go. Let's go. So we're going to do, we're only going to do the stats paper because I quite agree with Stephanie. Me nattering on for an hour and a half is not a good look in that people can't really follow it for that long. I get that. I mean, it was hard for me to speak that long as well. So, who's that? Someone else that just showed up. There we go. Hey, Ida, good to see you. It's good to see everyone's here. Brilliant. Okay, let's start. So we'll start. Just going to do the stats paper. It should take about 40 minutes, and that's us done for today. I haven't had any news about what happens after Easter, so at the moment, as far as I'm concerned, we'll do the mechanics one after Easter. All right? Thank you, So question 1 was histogram's question. 1A, 1B, 1C, 1D, 1D. Has everyone got the paper open and can see the paper now? If you haven't popped your name in the chat box, again, pop it in the chat box for me. Because I think I've got most people at this point. Can everyone see the paper, question 1? And then can I kind of get a bit of feedback? Do we need to see question 1 demonstrated? And if so, what parts of question 1? So I'm asking you, open up the stats paper. You've now got the mark scheme of the stats paper. Yeah, no worries, no worries. As I said, we're not going a full hour and a half, so we've got time to be flexible. Part C, histograms has generally confused you. Okie dokes. That's a fair shot. Okay, in terms of the histograms generally confused you, hey, good to see you, Amsel. Good to see you. If anyone else hasn't popped their name in the chat box, please do. We're up to about 14. I don't think I've got 14 names. Okay, so the difference between A-level histograms and GCSE histograms is that A-level, it was always, you could just use this formula, couldn't you? Go frequency equals frequency density times class width, yeah? And that was always true, all right? That's not true here at A-level, because at A-level, there is a, 1C and 1D, I think that's consensus on this. I think for this particular thing, we've got this issue that that's not always true at A-level. Sometimes there's a multiplier, yeah? So it could be frequency density times class width times by some constant, all right? And that's what makes A-level histograms different from GCSE histograms, all right? So let's have a look at the questions asking. So we've got 1A, 1B, 1C, 1D. Here we've got 5 to 7 has a width of 1, okay, fine, and a height of 5, okay. So width of 1 and a height of 5. So what we know is our bar for that is 1 centimeter across and 5 centimeters high. So it means that the range of 2 would count as 1 centimeter, yeah? So from 7 to 10, you'd have a range of 3, and if you drew that, it would be 1.5 centimeters. And it also seems that the area of it, 5 times 1, you double to get the frequency. All right, so those are the basic ideas. So if we're going to do the 14 to 18, so I'm ending up doing, just to show you how this works. So from 14 to 18, you'd have a 2 centimeters across there. You'd have a 4 centimeters across there. Yeah. All right. So that's what it would look like. And it would just, the answer should just come out as 4 times 4, which is 16. All right. Let's check I got that right. Yeah, so 16. There we go. So that's part A. Part B asks you to find out the estimate the mean time. That's just once you've got both the values for this. So 18 to 20, you'd get what? Basically just do 120 minus the previous 4 to get 18 to 20. Then it's just mean from the table. So number 1, A and B, I don't think are too particularly difficult. C and D, show your working. Explain whether any of the times by these applicants might be classified as outliers. Okay, cool. That's actually not too difficult. So the first thing you need to do is find your lower and upper quartiles. So what you need to do is go, the lower quartile is going to be 120 divided by 4. It's going to be your, what, 30th number? And your upper quartile is going to be your 90th number, which is 120 times by 3/4. That's your 90th number. Okay. So you've got the 30th number and you've got your 90th number. You need to find out what those numbers are. And the way you do that is linear interpolation. All right. So if you remember how linear interpolation works, that's not hopefully too difficult, but let's find out if people do. All right. So just, if everyone would just pop in on the chat, do you need to see this one done for part C? Or is it enough if I just explain what linear interpolation is? Or do you want me to actually demonstrate linear interpolation? I'll wait. So the question I was asking you is, do you want me to demonstrate the linear interpolation for lower quartile, upper quartile? Can I just quote the answers? Do you need to see linear interpolation done? Don't need it, just explain it. That's one of each. Okay, cool, quickly. I'll do one. I mean, you see one, you've got the idea. Okay, cool. So here we want the 30th number. If we do cumulative frequency on the table you're given, your table would go, I'm going to rub that out so you know you're looking for the 30th. I'll put that 30th there. The cumulative frequency would go 10, 33, what was it, 84. Then the next one you get 16 more, don't you? So it's 100, 120. So that's your cumulative frequencies as it stands. Yeah. From there, we need 30th. So we're going to be in this group, and this group belongs to, what is that given as? Let's pop that up. Ugh. 7 to 10. We don't need to do any continuity correction because it's nice and continuous. That's no problem on that. So the inequality sign's on the other one. Sorry, the equality sign on the other one, so 7 to 10. So we know our lowest value is 7. So that's our lower bound. Do you remember the formula goes, let me write out the formula. Lower bound plus need over have times by class width. Okay, so that's the formula for linear interpolation. Your lower bound is 7. I need 3. Sorry, I need more than 3. I need 20 out of 23. And then I need to times that by a class width of 3. All right? And that should give you the value that you're looking for. All right? So that's the example of linear interpolation on 30. 90 would work in a similar way. Let's just check if they got the same thing. And that's how you'd find the lower quartile. And you'd find the upper quartile in a similar way. So if we do that in a calculator, you get 7. Let's just do the 20 over 23 bit first, because that's the best bit to get done early. Times that by 3. Add that to 7. And you get 9.61. So your lower quartile is 9.61. All right? is everyone reasonably happy with this idea of yeah, I mean, do it whatever way you want. I didn't bother doing the Adidas method mainly because I haven't got the space on the whiteboard to draw it. But yeah, it's that. It's also, you can just use the formula. Lower bound, need is how many more you need after the last one. So here you've already got 10, you need another 20 to get to 30. So that's why it's 20. You have 23 frequency in that group. So 20 over 23. And your class width is that minus that. And the only thing you need to remember is what if I have to do a continuity correction? And that's that, I guess. All right. If you do it the same way, you get, so this is your lower quartile. Your upper quartile, I'm going to put next to, I'm just going to now state it because I presume, hopefully that's enough of an explanation. Your upper quartile is going to be 15.5. All right. And again, you can check this later in your own time to see if you get this right. And that would give you an interquartile range of about, what's that going to be? 5.5, 5.89 roughly. Yeah, you want to check that for me? 5.89. Okay. So far, so good, right? Is everyone happy up to this point? So we've got an interquartile range of 5.89. All right. Because the upper quartile is 15.5. I've shown you how to work out the lower quartile. The upper quartile is just the same way, just you go for 90 rather than 30. Okay, cool. So what do? You take that 5.89 and you take it away from your lower quartile. So we've got 9.6 minus 5.89. And then you add it to your upper quartile, which was it 15.5? Let me just check. But you've got to times it first by 1.5. Because it says 1.5 times the interquartile range. So two sums you need to do. 9.6 minus 1.5 times 5.89. And 15.5 plus 5.89 times by 1.5. And that's going to give you a band of numbers, right? So we're going to do those calculations now. And I'd get... So what is 5.89 times 1.5? So I'll read that repeatedly. 8.835. 9.6. So you get 0.765 for this. And for this, you get 8.835 plus 15.5. And that gives you 24.335. Now, what's the value of these numbers? Why have I created them? Where do they all come from? What's the situation, right? What situation is this? If your number is larger than this, you're an outlier. If your number is smaller than this, you're an outlier. So if we go back to the original data, have we got any outliers? So we have a look at this. This is showing your working. Explain where any of the times taken by the 120 workers. So we've got 24.4. There's a decent chance that some of the 18 to 30 group is going to be above 24 and a bit. Therefore, it's likely there's outliers. All right? It's likely there's outliers. I hope that's making sense. All right? You happy with that? Brilliant. Okay, good. Okay? So what you do is you create the bounds, basically. And the bounds are your lower quartile minus 1.5 times the interquartile range and your upper bound plus 1.5 times the interquartile range. All right? And from there, if any number is outside those numbers, so is it smaller than the smallest or bigger than the larger bound, then they're outliers. Now, the question is kind of phrased weirdly, but it's basically saying to you, well, look, is there a chance that you've got outliers? And yeah, probably there is, because 18 to 20 has 12 values inside there. So 18 to 30 has 12 values inside there. And 24 is only halfway. So there's a decent chance there's outliers. All right? Quickly just finish off 1D now. Hopefully it's quick. I can see the question might be long. Estimate the time. Candidates 5% times of given interviews below which they might be given an interview. Okay, so 5% is your fifth percentile. Yeah. Guess what? You're just doing linear interpolation again. Okay. 5% of 120 is 6. Yeah. So you literally just do linear interpolation off your sixth value. Yeah. And find out what time that would be. Does that need to be demonstrated? Yeah. Does that need to be demonstrated? So it's just, you want to find out how long does your sixth value take. So I'm just going to wait in the chat box. If anyone else needs any kind of like more description on B on D, let me know. Pop something in the chat box for me. Yeah, you happy with that? I mean, it's not particularly onerous at this point. Excuse me. All good, excellent. It's just the same question again, right? And remember, you have got mark scheme for all this stuff and the rest of it. All right, so that's cool. That's one down. Let's roll. For number 2, does anyone need any of number 2? Take a minute or two to kind of consider it, and then let me know. So I'm going to look at some of the further questions. You've got number 3. So binomial. Number 4. I think, is that it? Is there a 5? There is a 5. Okay, so pop in the chat box if you feel like we need to do number 2. Yeah? All right, so anyone also hasn't put their name in the chat box, put that in because I'm going to do register very, very shortly. So I'm just asking you in a moment, can you type in whether we need to do number 2 or not? So yeah, Usna saying we'll do it. That's fine. We can do it. It's no problem. Other people's opinions, if you don't mind. You need part B, don't need 2. Okay, cool. So I might do 2B in detail and then kind of like just analyze quickly how to do it for the rest of it. We'll see. How many other people, what's other people's opinions? If everyone wants to do 2, I'll do it in detail. I'm going to keep this video short, whatever happens. So don't feel like it will stretch the video out. We'll just do it over loads of parts during different lessons. So don't think like, oh my God, I can't ask for this because I don't want this video to last 2 hours. Well, it's not going to last 2 hours, whatever happens. Let's do it. Okay, fine. Let's do it. So 2A, it's a normal distribution. Find out the probability is exactly 31, 0. It's normally distributed. Find out it's more than 31. That's again just using your calculator with this formula. Or to be fair, you can just literally just use your calculator. Does anyone not know how to use their calculator for part A? So I mean, that's a gimme, yeah? Can you, again, I need your feedback on this. Seriously don't know how to use a calculator for part A. All you've got to do is go to menu, 7, normal CD, all right? Set your lower and upper bounds as appropriate. So here your lower bound would be, what's the question I'm asking? Your lower bound would be 31. Upper bound would be 100,000. Put in the numbers and press equals. Hopefully not too bad. Yeah? Is that making sense? Let's just show that. That's 31. This is 100,000. And 1 for some reason. They give you standard deviation and mean. They must do worse than possible to the question. 30 and 2. Yeah, so 0.308. Let's see if we're right. Let's roll around. They're not particularly difficult. So part A should be really super easy. Yeah? Okay. Part B is the one that was requested. Only the 1st, only the 8th, more than one of these days. So that to me looks like a binomial. Let's have a look. Yeah, it's binomial. So part B was simply binomial. So if you wanted part A, part B, only on the first of on the 5 days, this is the sum you do. You just literally go 0.00668 times 1 minus 0.0668 to the 4. Why? First day, second day, third day, fourth day, fifth day. Boom. Yeah? And then the second one, you just do x is binomially distributed on 0.0668 and find probability that probability that x is greater than 1. Yeah? If it's so more than more than 1, so greater than 1. So you do 1 minus the probability of 1 or less on your binomial CD. Does anyone need to be taught that again? Pop that in the chat box. It's like part A and part B seem pretty simple. Yeah? So for part B, the first one is just write out the probabilities if it's a tree diagram or something. And the second part of part B is, it's binomial. What's the probability of greater than 1? 1 minus the probability of less than 1, and including 1 as well. All right, so it's just that. Okay, what's left? That seemed to be a pretty simple question, actually. Find the mean water temperature. On hot setting, the mean temperature is modeled by a normal distribution, standard deviation 1.5, more than 42, 0.05. So find the mean water temperature. Okay, that was a bit more of an interesting one. Okay, that was much more of an interesting question. It was one of those where you don't know something and it's like you have to solve the equation finding mu and sigma. So you know that H is normally distributed with a mean of mu because that's what you're looking for, and a standard deviation of 1.5. That hasn't changed. It was the same as before, I think. No, it wasn't. It has changed there. So we know that the probability of, I'm going to do it this way around because it's slightly easier. Probability of H being greater than 42 is 0.0005. All right. So what we can do, there's two choices on that. Either use the formula booklet to look that up, and get that's if you do the normal distribution, that's 3.29, or you can work this out in your calculator. So the Z value of that is 3.2905268. All right, 3.9052658. Now, can you pop in the chat box if you know how to find a Z value? All right, because I don't find that difficult, but I don't know if you do. Just a quick, I'm going to do it myself on a calculator just to show that you don't need the table if you don't want to. So you know how to find it. Brilliant. Sorry. No, we're going to use that, but that's not what I'm asking. I'm trying to find the actual Z value. Nope, that's not what I'm talking about here. Absolutely not. What I'm saying to you is, how did I know that just from that I could get this Z value? And I promise you, you can't. It's not a formula thing. It's either a calculator or a table thing. I want to know if you know what you're doing, and I'm guessing no is the answer to that. From what I'm saying. Okay, here's how you do it. So you go to menu, right? You go to distribution, and you go to inverse normal. Yeah, you can use table. That's fine. Type in the area, and for the area for this guy, it's not going to be 0.05. It's going to be 0.9995 because the calculator deals from this way, doesn't it? So I want this number Z. So I need this value here, and that's just 1 minus this. All right, so 0.9995. That's your area. Your mu is 0 and your sigma is 1 because Z is standardized normal. Yeah? Everyone's using that formula. We're going to use that formula in a minute. But to be able to use that formula, we need to know where this number comes from. And that's what I'm explaining now. So your area is going to be 0.9995, and that's what you enter into your calculator. As we know for Z, mu is 0, sigma is 1. All right? Yeah, we're going to use that formula in a minute, but not yet. And when you type down your calculator, your x inverse value is 3.2905. Okay? And now we know what Z is. So basically, the thing I'm asking is, what value is this thing here that I'm going to put equal to that equation? Yeah. Standard normal in the values. That's right. Yeah, U0. That's it. Now you are understanding what I'm challenging here. Can we create the number? And you can do it either by formula. You can do it by formula. I mean, that's fine too. There's no issue about that. But okay, cool. So we've got the value now, right? So now we can, you know that thing you were telling me, all of you guys, x minus mu over sigma. We can now do that. Well, we know x. Well, do we know it? Let's see what we've got. There we go. Yes, we do. We've got 42, which is obviously your x, I'm being stupid now, I even wrote it down, minus mu over sigma, which is 0.005. Sorry, sigma is, what is sigma here? We're told sigma is 1.5. Yeah, now we can solve it. But the key point was finding the 3.29. Once you've got that, we're in place. I hope that makes sense. All right. Can you pop in a chat box if you didn't understand this, or there's any particular issue that you've got with it? So the key point, I think, here was knowing that you needed a number here to make it work. Because all the other numbers are sort of given to you. And it's like, can you make the step from here to there? If you can solve quite nicely. So pop back your feedback in the chat box. As always, if you haven't kind of registered your name, pop your name in there as well. Probably last time I would say that. I don't think anyone's coming in now. Okay, brilliant. Hey, Aisha. Let's move on. So question 2 done. I don't know how many more time we've got time for today, but we'll try and do as many as we can in the next 15 minutes and call it quits there. Do we need to do number 3? And if so, what parts of 3? Do we need to do number 3? And if so, what parts of 3? So take a minute to have a look at number 3 and tell me if there's any part of 3 you want me to do. And if so, which parts of 3 would you want me to do? So I'm basically waiting on your feedback on this. Should we do 3? And if so, what part of 3 should we do? (3A), okay, let's have a quick look at 3A. Well, this is sort of a common sense one for part A. State the probability that the cardinal wind direction is assuming that every probability is equal, right? It would surely go, is it 1 over 16, if I remember how weather things work? I'm just going to check that. This is more about like general knowledge of how things work. Yeah, it's 1 out of 16. Right, here's how I'm going to explain that. It's really simple. Here's the directions you're allowed, yeah? So you go north, northeast, north, northeast, And then what's the next one after that? I think it's that way around. Right? North, northeast, northeast, east. Actually, hold on a minute. It's east, northeast then east. Then you've got east, southeast, south, southeast, south. And if you think, okay, what the flaming hell are you playing at VJ? I have no clue what the hell you're talking about. No problem. Literally, that's been dredged up from my memory since geography 15, 20 years ago. I'm going to email my colleagues and I'm going to see like who the hell actually taught that. So basically, here's how it works. If you're living in north, east, south, and westland, you've got 4 directions. If they start talking about northeast, southeast, and all the rest of it, you know, northwest, you've got more, clearly. You've got 8, I think. And if it goes to 3 letters, so north, northeast, you've got 16. That's the only thing you need to remember. Yeah? I know there's more than that. But the answer is 1 over 16. All right? And when I mark that, I'm going to ask around whether we can like knock a mark, give an extra mark for that. Because I know, I'm not going to lie to you on that one. As sure as hell I didn't teach that. I don't think anyone else did either. So yeah, unless you did geography, I don't see how the hell you'd get that one. But hey, you know it now. Yes, that sounds like he's insane, but he's actually right. That's what a compass looks like. That's a northeast, southwest. That's a north, northeast, east, southeast, south, southwest, west. Yeah? And then just imagine each one of those split in half as well. So you know my beautiful drawing skills. So imagine draw a line here. Oh my god, I hate my life. Why did they ask that question? You get the idea, yes? There's like 16 of them, all right? But don't stress about that. I'm going to see if we can get that one knocked off. Now you know it. You've learned some geography in my class. So yeah, don't stress about that when I'm marking it. We'll see what we can do about that. Okay, so that's 3A done. No, it doesn't actually, because it says 3. What's the other thing? What's the right distribution for that? This one you should know. It's going to be a... That's a good idea. It should be a... discrete uniform distribution. Why is it discrete? Because each one of the 16 things are discrete, yeah? Each one of the 16 directions is discrete, and each probability is equal. So discrete uniform distribution is the answer to that. Okay, 3B. These are all kind of things. Do you know stuff about the large data set, which we've talked about before? And part C is, can you do a random number generator? Do you know how to do a simple random sample or whatever, right? So let's have a look at D, because that was one that was asked. Bear with me just a second. So what was asking in D? So D, they ask, all you need to do is work out the 0.25, right? Critical regions 4 and 14. X is 15. So obviously you're going to reject null, all right? Because X is in the critical region. And the alternate hypothesis would be, for the first part of D, is, what's it asking you to do? What's it say? I'm trying to work out what it's a two-tailer, definitely, but what sort of test is it? Random number is a yet 60 to find X is 15, and the critical region is that. So bear with me just a second. We'll see. Yeah. So yeah, so this is basically a two-tailed test. So if it's a two-tailed test, by definition, we are talking about the hypothesis. The null hypothesis would definitely have to look like this. All right. And I don't know why I was being dumb about that. Obviously, because it's a two-tailed test, you'd have that rather than an inequality going either way. Is that all right? That's all there is. So for part D, it's very, very simple. You know you're going to reject the null hypothesis because it landed in the critical region. 15 is in the critical region. And because it was broken up into two parts, the critical region, you could tell straight away that the alternate hypothesis is the probability is not equal to 0.25, not that it's less than or greater than. All right, that's all there is. So that's 3 done, and we haven't got many minutes left, so let's push on. Quick look at number 4 for me, and then feedback of anything you want to see. What's on 4? 4 is just like standard deviation. And normal again. Does anyone need to see it? What do people want to see out of 4, if anything? So I'm saying no for 4. Get a few more people's kind of input on this. Remember, if I feel like the video is going on for too long, I can easily just say, okay, we'll pick this up after Easter. So don't stress about, like, I don't want to ask because it will make the video drag on too long. Right, most people are saying no for 4. Have a quick look at 5. 5 is just a straight prob one. Let's see what people think. So saying, like, most people saying no for 4, good. How about 5? 4B quickly, why not? Let's just do 4B quickly. Where's 4? So test at 5% level of significance about Lucy's time trial. So what would you need to do? You've got to first state your hypotheses, which is that H0 is mu is 27.5. So it's mean times we're talking about here. H1 is that mu is greater than 27.5. Okay. And then you'd work out your statistic. Yeah. So 5% level of significance is 1.96, isn't it? If I remember correctly, for Z values. So the way you do it, you go X bar. Remember, this is modeled by N on 27.5 3 squared over 60. Why? Because there's 60 pieces of data. You remember that from before. You find Z, which is 1.2909. Yeah. The critical value, sorry, I got that wrong. The critical value is Z is 1.64. So this is what you get. That's what it needs to be a critical value. So I take that back. It wasn't 1.96. That's the other one. Therefore, we don't reject null. We don't reject null. All right. Simple as that. Hope that made sense. So basically, what you needed to do here was work out the Z, show that the Z is less than 1.64. So that's how you do 4B. Are those people that heard that satisfied with that explanation? So for 4B, you create your normal distribution. Because it's coming from a sample, you do divide by 60. You work out the Z value and show that the Z value is less than the critical region for a 5% test. So pop it in the chat box if you find that's useful. I feel like we might just be able to finish this thing in about 5 minutes, if that's the only thing you want to see from 4. So have a look at the rest of 4 and 5 and see if you want any more if you want any help on either of those. With regard to 4B, the people that asked, are they satisfied with it? Kind of need some feedback on this. So again, pop it in the live chat for me what you want to do from here. Do we need any more 4? Do we need any 5? Pop it in the live chat for me. Did we understand 4B for a start as well? So 4B makes sense. 5. Okay, so the last bit of 5. I'll move on to that. So that's 5 second B. Yes, certainly. Okay. All right, so the second one, so that's literally the last one of the whole thing, I think. Let's have a quick look at that. What's that even all about? Okay, formulas you need to know. This one has been taught. Probability that C given D is the probability of C and D over probability of D. So you need that formula. And you've been given some information, right? You've been given that. Let me just find out what you've got. The probability of P, C, and D is 3 times the probability of P and C. So that's going to be, so you can go straight into this, yeah, without too much effort. And you've got this guy here is the probability of C and D is a half times probability of C. So you can write this too. And that's now going to give you the probability, and here you've got probability of D. All right. So is everyone happy with the first line? I've just applied the information that they gave me in the question to get to that more simplified version. All right. It's then quite logical to work out just by rearrangement, because the probabilities of C will cancel, but the probability of D is 1/6. All right. So those first 3 lines, do they make sense? This is the formula you needed. This is a substitution into there. If you rearrange this, the P over C's, the probabilities of C's will cancel, get probability of D is 1/6. Right? There we go. Nice and easy so far. So we've got up to that point where we know that P over D is 1/6. Let's keep moving. All right. The next thing is we know that the probability of not C and not D is 7/10 because that's given in the question. So we know logically the probability of C or D equals 3/10. Now, where does that come from? If you draw the Venn diagram, it kind of makes sense. The probability of not C and not D, so we just draw the circles. So not C and not D, so this guy here. Sorry, not this guy there. So not C and not D is basically the outside, isn't it? Yeah. So not C and not D is the outside. So C or D, and I said that's 7/10. So what's this, which is this guy, is 3/10. All right. So that makes sense to people. And then the final thing I'm going to go is go probability of C, and using this formula, probability of C UD. This is from GCSE now, yeah? Equals the probability of C plus the probability of D minus the probability of C and D. Okay, just going to use that formula. And I'm just going to plug in the bits and bobs I've got now. So I know that's 3/10. I know that this here is, what have I got? Probability of D, so that's just going to be what, once. So 1/6 on that. I've got the probability of C is what I'm looking for. That's probability of C. And I know that this is a, what was that? It's a half of probability of C, if I remember correctly. So that's minus a half probability of C. And you can just solve to get what probability of C is, and that's you done. That's you finished. All right. So that was the mathematics behind it. And I actually don't think that's too difficult if you run through it. Can you see all of it? Yeah, you can. Okay. And that's us done, I think. That's done. That's done for today. Just those who came in late, no new information about anything. So as far as I know, as of today, as of this minute, I'll see you guys after Easter. If I get any further news, I'll pop something on the messages, but you'll probably get emailed by the college first because they get information faster than me. So after Easter, we'll have a look at mechanics and we'll discuss whatever needs to be discussed. My message is always open, so if anyone's kind of finding it hard, struggling, needs help, etc., feel free to drop me a message, all right? Whatever happens, we'll meet again somehow, all right? That's me done for today. Hope everyone stays well over Easter. Take care of yourself. If you need anything, as I said, please reach out, all right? I'll hang out there for a few minutes in case anyone's got questions, but I am done and you are free. In fact, what are you doing? So if anyone needs anything or wants to needs any kind of like information or support or whatever, hang around here, but I'm done. You're free to go. Take care. Bye, Steph. I'm working on your thingy. All right, so don't worry about that. Katerina, have a good one. I'll see you around. Please save this life. I always save them. Will we do the spreadsheet for marks? Yeah, I mean, you should have said that. Yeah, it's not like I'm completely disappearing over Easter. I'll get all this stuff out for you. Happy Easter. Yeah. Feels weird. It isn't a holiday, is it really? Yeah, so keep your eyes open for things like the spreadsheet and your stats and mechanics marks, because I'll be marking them over Easter. Silly. Take care. Bye, Aisha. Have a good day. Yeah, so you will hear from me. It's not like I'm disappearing off the face of the earth. Evie, have a good one. Husna, take care. Let me pop everyone in the register. Let's see if there's anything there. When do you want a spreadsheet by? This side of, like, by the end of the Easter holiday, all right? Because it doesn't need to be due until the second, so the Tuesday after the Easter holiday. So that's like nearly 3 weeks away. So 19th, 18th, 19th. You'll have plenty of time to do it, I suspect, all things considered. So yeah, I'm done here. So unless you've got any particular questions, please leave, because all I'm going to do now is the register, and that's I've got everyone's name down. I've even heard from Frampton Clark, believe it or not. I mean, who still plays Angry Birds? My dude, seriously? I wonder, eh? Okay, just wait for this to load up. All right, we're done. Easter's 2 weeks. Yep. Take care. Bye.